Hello all, welcome back. Now we are going to look at third lesson of network traffic management, and in this lesson we cover Azure Traffic Manager. If we look at the different topics in this lesson, we will see what is Azure Traffic Manager and what are its features, different routing mechanism, and how exactly we can implement a traffic manager. So Azure Traffic Manager is a way to route traffic to different endpoints which is distributed across the globe, and it uses DNS as a routing mechanism for the traffic. This is Azure global resource. So even if there is issues with one particular region, we can use Azure Traffic Manager to route the traffic across the regions. So in cases of disaster recovery, this will be very much helpful. If we look at the traffic flow with Traffic Manager in the picture, first a user queries the DNS server using the Traffic Manager endpoint, and the Traffic Manager endpoint will pick the right backend IP addresses from the backend pool, and it will return that IP address back to the browser or the client. And the way it chooses the right endpoint is based on the routing method which we configure, which we will see in the subsequent session. And once the user get the IP, the user will directly try that IP behind the scenes. So this IP will be cached in the user's local for some specified amount of time, which is actually the time to live which is configured for this traffic manager. Here, even in case the traffic manager goes down, user will not be uh, seeing that impact. The reason is that the IP address is already cached for quite some time. So that's why user will always get 100% SLA for traffic manager. And the disadvantage of the traffic manager is that in case if for DR scenarios, if we use a traffic manager and if the time to live is quite large enough, say for example an hour, then for the first request, user will get the primary data center region, and that is cached for next 1 hour. Whereas in next 15 minutes, the primary data center goes down, and if we switch back to the alternate DR data center, ideally the traffic should flow to the DR data center. Whereas due to the 1 hour TTL and the IP is cached for the user, he will be still routed to the first data center for next 45 minutes even after the downtime. So that's why it's always recommended to set the TTL to very less in case if you want to respond quickly for the failover scenarios. So we have a list of backend endpoints which is defined, and we can define the health checks based on uh, the different algorithms as well. And it's similar to what we see in Azure Load Balancer. Some of the advantages of Traffic Manager is that obviously since we can use it for DR purposes, it can improve the availability of the critical applications, and for high performance application, we can route the user to the nearest endpoint as well, and it helps in increasing the responsiveness. And we can use it for complex deployment, say for example blue green or canary deployment. We can effectively use the traffic manager, and we can create different profiles for different routing scenarios. Let's see what is priority routing mechanism. Whenever a user requests for the URL, the traffic manager will create a list of available backend endpoints, and it will assign a priority for each and every endpoint. So in the example which is shown in the slide, we have a primary endpoint which has the priority 1, and we have two different failover endpoints, failover A and failover B, which has priority of 2 and 3 respectively. And it will check the status of the endpoint to see whether it's degraded or online based on the health check. And it will create the priority table available, and whenever the user requests for the DNS query, it will always pick the first endpoint. If the status is online, it will return the first endpoint. It will go to the next endpoint only when the priority 1 endpoint is not in a healthy state. That's what we call it as priority routing. And next is what we call performance routing. Here, instead of arranging the backend endpoints based on predefined assigned priority, it will try to construct a lookup table, and based on the DNS queried client IP address, it will create the table to check what is the latency across different backend endpoints. One example might be if we have three different endpoints, one in West US, one in North Europe, and one in East Asia, and if the user request is coming from somewhere in Australia, it will try to look up what is the latency for the Australian IP address to all these three backend endpoints, and it will create the latency information in the table. And based on that information, if the latency is, say for example, 150 millisecond in East Asia and some other in others, it will pick the lowest latency endpoint and it will return to the user. That's what performance routing is. So next category is geographic routing. Here we assign certain endpoint to a particular geography. Say for example, if we want to serve all European users to a particular European endpoint, irrespective of the case, then we want to create geography based routing, and if the source IP address or the client IP address is from Europe, it will always return the European endpoint. So that's how we can configure geographic routing. And the next category is weighted routing. What it basically means is that for each and every endpoint, we can define a weightage, and based on that weightage, it can share the or split the load. For example, in the picture, we have region A which has weight 50, and we have two different regions, test A with weight 5 and region B with weight 50. Now, if the region A is healthy, obviously it will split the load into three equal uh, three set of categories. The first, when it goes to region A, it will send almost nearly half, and region B it will be nearly half, and for test A it will be very small or a fraction of load. Whereas if region A goes to unhealthy state, then out of 100% of the load, test A will get 10% of the load, whereas region B will get remaining 90%. So that's how the load is splitted based on the weight we define in the weighted routing mechanism. So coming to the actual implementation steps of traffic manager profile, we have to choose the routing method while creation of the traffic manager, and we have to define what is the TTL which we need to use. And we can choose what is the backend monitoring mechanism, whether we want to monitor through HTTP probe or HTTPS probe, and we can define the backend port information and the path URL, and that will help in checking the health status. Once we create the traffic manager profile, we have to add the endpoint, and there are two different endpoints which we can use. One is Azure endpoints and another is external endpoints. So we need to use Azure endpoints if we want to use the backend as either the Azure Cloud Service or Azure Web App or some public IP address in the same subscription. So if we choose that, we can use the drag and drop and pick the right results, and we can configure. Otherwise, we have to use external endpoints, and with these external endpoints, we can even use some arbitrary public IP address or fully qualified domain names, or even some public IP address in on-prem as well. So we can really build a truly global application, because Traffic Manager spans across Azure or on-prem or any other cloud provider as well. If we look at the difference between Traffic Manager and the Azure Load Balancer, Azure Load Balancer works at transport layer or layer 4, that is TCP and UDP, whereas Traffic Manager works at DNS level. And coming to the protocol support, Traffic Manager supports only HTTP and HTTPS endpoint, whereas Load Balancer supports both UDP, TCP, etc. And Traffic Manager supports almost any endpoints, either it can be cloud, on-prem, or any other cloud provider as well, whereas Azure Load Balancer supports only the Azure based endpoints like VM, cloud services, etc. And we can configure Azure Load Balancer as internal and external load balancer, whereas Traffic Manager is always external internet facing. We can also use mix and match. Say for example, in a DR scenario, we can use Traffic Manager as first level of routing mechanism, and once we route it to the right region, we can use Azure Load Balancer to build HA in that particular region. Like that, we can use mix and match across two. Now let's switch back to Azure portal to see how we can create a traffic manager. Let's search for traffic manager profiles. Create traffic manager profile. And let's create some unique name. So this name should be unique across the internet because it's a DNS endpoint. And let's pick a resource group. And since this is a regional, not a regional resource, we don't need to choose any particular region. And let's click on create. And it's currently creating a new profile. So now the traffic manager profile has been created. Let's refresh it. And go to resource. So here we see all the traffic manager information. And under the configuration, if you want to change some of the settings like TTL, or if you want to change the routing method, we can configure it under the configuration. And next thing is configuration of endpoints. So this is where we need to add all the backend information. Let's say if we want to add a endpoint, and if we want to add an Azure endpoint, we can add it, and we can name the endpoint, and we can choose the backend service. Whether if you want to choose a public IP address, we can choose it, and we can pick the public IP address as well.